All right, let's talk about something that drives everyone crazy with AI chatbots, their terrible memory. We're not just going to complain about it, though. We're going to solve it. We're going to build a bot that actually remembers things using two incredibly powerful tools that are really changing the game for developers, LangChain and Pinecone. Okay, let's dive in.
So you know the feeling, right? You're in the middle of a great conversation with a chatbot, you ask a simple follow-up question, and nothing. It's like it has no idea what you were just talking about. It's a super common problem, and the reason for it is actually pretty straightforward.
You see, the problem is that most of these big language models are, well, stateless. They're amazing at what they do for a single turn of conversation, but they don't have this built-in, persistent memory of your specific chat. It's like talking to someone with no short-term memory. To build something genuinely useful, we have to give our AI a way to remember what we've said.
So how do we fix this amnesia? Simple. We give our AI a brain and a memory. And for that, we've got the perfect duo. We're going to use LangChain to act as the brain, or the logic center of our application, and we'll use Pinecone to be its powerful, searchable long-term memory.
First up, let's talk about LangChain. Now think of it less like the AI itself and more like the conductor of an orchestra. It's the framework that connects all the different pieces. It manages the flow, handles the prompts, and tells the language model what to do and when to do it. It's the central command center for our entire operation.
And that brings us to Pinecone. This is where the magic of memory really happens. Pinecone is what's called a vector database. So what on earth does that mean? Well, instead of storing words as just, text, it stores their meaning, their context, their vibe as a string of numbers. This lets our AI find the most relevant piece of information almost instantly, even if our follow-up questions don't use the exact same words. It's searching for meaning, not just keywords.
Okay, so we've got our brain and we've got our memory. Now let's pull up the blueprint and see exactly how these two work in harmony to take a simple question and turn it into a really intelligent, context-aware answer.
So check this out. You ask your chatbot a question. LangChain, our conductor, intercepts it. But, and this is the crucial part, instead of just passing it straight to the language model, it first taps Pinecone on the shoulder. It asks, "Hey memory, have we talked about anything like this before?" Pinecone zips through everything it has stored, finds the most relevant bits of past conversation or documents, and hands them back to LangChain. Then, LangChain bundles your new question, plus all that juicy context together, and gives it to the language model. The result? A smart, deeply informed answer that actually makes sense.
All right, and enough with the theory. It's time to get our hands dirty and see what this looks like in practice. We're going to peek at the actual Python code that makes this all happen, and I think you'll be surprised at how clean and simple it really is.
First things first, before we can do anything else, we have to establish the connection. We need to tell our code how to find and talk to our Pinecone database, which is going to be our AI's memory bank.
And honestly, look how easy this is. With just these few lines, we're in business. We import the Pinecone library, and then we call init. All it needs is your personal API key for authentication and the cloud environment where your database lives. And just like that, the communication line to our AI's memory is wide open.
Okay, next up, we need a translator. We have to turn our human language, our text, into that special numerical format that our vector database Pinecone can understand. And these numerical representations are called embeddings. You can think of an embedding as a kind of GPS coordinate for a piece of text's meaning in a giant map of ideas.
And this is where LangChain really shines. It makes this process ridiculously simple. We just import the OpenAI embeddings tool from the library and create a new instance of it. That's it. This little embeddings object is now our powerhouse. Anytime we need to turn text into numbers, whether it's to store a new memory or search for an old one, LangChain just handles it for us. All the complex API calls are hidden away. Now for the grand finale of our setup. This is where we connect the brain to the memory. We're about to wire up LangChain and Pinecone so they can operate as a single intelligent system.
This one line of code right here, this is the handshake. This is where the magic happens. We're telling LangChain, hey, I want you to connect to Pinecone, and I want you to use an index I've already created. We just give it the name of our index and the embeddings tool we set up a second ago. This docSearch object is now our gateway. It's our tool for both adding new information and, more importantly, searching for that crucial context to answer questions.
So we've built the connection, we've wired everything up. Now, so what? What does this actually let us do? Well, this is where we graduate from a simple, forgetful chatbot to something with some truly powerful real-world applications.
Look, this architecture is a total game changer.
It means you can build a chatbot that actually remembers you and learns from your conversations over time. You can point it at your private data. Think company wikis, personal notes, your own knowledge base, and it can use that information securely without ever sending it to a third party. This lets you build a truly personalized AI assistant that understands your world and gives you the context-aware answers you actually need.
So I'll just leave you with this one thought. Now that you have the blueprint to give your AI a real, functional memory, the question isn't if you can build a smarter AI anymore. The question is, what are you going to build with it? The possibilities are pretty much endless. Thanks for tuning into this explainer.